Hi, dear students. This topic is heterocyclic compounds from the subject Pharmaceutical Organic Chemistry 3 for BPharm C as per PCS syllabus. In that subtopic is classification and nomenclature of the heterocyclic compounds. We'll see this topic one by one. So before start the sessions, I requested to you all dear students to subscribe my YouTube channel for further notification of another topics from the pharmaceutical organic chemistry. So subscribe that accordingly. Okay. So what is the meaning of heterocyclic compounds? We will see this content in this slide, that is the definition meaning of the heterocyclic compounds, then heterocyclic compounds and their classifications, and then nomenclature, how to nomenclature to the heterocyclic compound, different heterocyclic compounds. Okay, so first of all we will understand what is the meaning of heterocyclic compound. So, see, the heterocyclic compounds are those cyclic compounds in which one or more of the ring carbon are replaced by another atom. Okay, another atom means that is the nitrogen, sulfur, okay, oxygen, etc. The non-carbon atoms in such rings are referred to as a heteroatom. Okay. So most common heteroatoms are nitrogen, oxygen, sulfur, then boron, phosphorus, etc. These are the different heteroatoms which are attached to the rings, okay, other than the carbon atoms, that we can call as a heteroatoms. So heterocyclic compounds are the cyclic compounds. It is a cycle form, okay, means 3-membered ring, then 4-membered ring, for 6-membered ring, 7-membered ring, etc. That is the cyclic form, and in which the ring system contains other than the carbon atom, such as the nitrogen, oxygen, sulfur, etc. These atoms rather than carbon present in the ring are known as heteroatom. So you understand what is meaning of heterocyclic compounds. Okay. So next we will go towards the classification of the heterocyclic compound. Simple way is that classifications according to the nature and the number of the heteroatoms present in the ring, number of the heteroatoms, different heteroatoms, okay, in the ring. That is example, see, azoles contains the nitrogen, thiophene, etc. Thiophene, that is yes. The degree of saturation, either it is aromatic or non-aromatic, either it is saturated or non-saturated, unsaturated, sorry. Then size of the heterocyclic compounds, that is number of atoms making up ring system, 3, 4, 5, 6, 7, 8, 9, 10 members, heterocyclic compounds. Then simple heterocycles, and last is the fused ring systems. So these are the some classification of the classification methods. This is according to these methods we can classify the heterocyclic compounds. See, first of all, 3-membered rings with the one heteroatom. See, this is the only one heteroatoms like nitrogen, oxygen, sulfur, etc. That only present in this heterocyclic compound. The classification containing 3-membered rings with one heteroatoms. Like, see, these are the nitrogens, oxygen, and sulfurs. These are the example of heteroatoms, and this table shows that saturated and unsaturated compounds. See, if saturated is there for nitrogen, it is we can call that azridine, and if suppose unsaturated is there, means azarine. See, the difference between saturated and unsaturated is unsaturated having the double bond, and saturated having it's not having the double bonds. Simple difference. Azarine, we can say oxygen, ethylene oxide, it is oxirine, then sulfur, thyrine, and the thyrines. Okay, so these are the 3-membered ring system with one atom, 3 membered ring with the 2 heteroatoms. Example is dioxazine and for nitrogen diazine. ओके आप आपको ये ध्यान रखना है कि कौन कौन से एग्जांपल्स है, क्या 3 members है, 4 members है, एक्सेट्रा. So 4-membered ring with one heteroatom, that is azitidine. These are the examples for saturated azitidine, azide, oxetane, oxide, thioetine, thiate. Okay, just remember that these examples with the practice. Next, 4-membered ring with the 2 heteroatoms, that is the nitrogens and the diazidine, dioxetane, okay, dioxetate, etc. Then 5-membered rings with 1 heteroatoms, that is a 5-membered. See, the structure is 5-membered ring with 1 heteroatoms. This also 1 heteroatoms. Only the difference is this is saturated ring structure, this is unsaturated ring structure. These are the examples with these different heteroatoms. Then 5-membered rings with the 2 heteroatoms, like see imidazolidine. It have nitrogen as well as the 2 heteroatoms. Imidazolidine, 2 nitrogen atoms here. Pyrazolidine, here oxazolidine, that is the nitrogen and oxygen. These 2 heteroatoms are present in the ring structures. Okay. Next, 5-membered rings with the 3 heteroatoms. 3 heteroatoms are present in that, like nitrogen. See here heteroatoms, nitrogen, 1 nitrogen is there and 2 sulfur is there. We can say that the name is dithiazole. 2 nitrogen, 1 oxygen, that is furiazoin and oxidazole. 2 nitrogen and 1 sulfur, that is thiodiazole. Okay, these are the examples of the ring systems. Next is the 6-membered rings with the 1 heteroatoms. Example is pyridine, okay, tetrahydropyrin, pyrrolium. Okay, these are the examples. Next is the 6-membered rings with the 2 heteroatoms. In that 2 heteroatoms are present: morpholine, oxazine, diethane, dioxane. See, you understand these examples and remember these examples. At least 2-3 examples you have to remember for the whenever you writing the classification in exam. Okay. Next is 6-membered rings with the 3 heteroatoms. That is example is thiazine, triazine, tetrazine, etc. These are the classifications of the heterocyclic compounds. You can write in exam. Next is the nomenclature of the heterocyclic compound. Basically, how to nomenclate one ring is there, heterocyclic compounds, you have to nomenclature that, so that these some rules are there for nomenclatures, you have to follow that. First is the IUPAC, then tribal names, common names. Next is the replacement nomenclature, and fourth is Hans Wildman naming system. So every nomenclatures have 3 main part, that is the prefix, stem and suffix. Okay, so what is the meaning of this prefix, stem and suffix? There are 4 rules for the nomenclature of heterocyclic compounds. First of all, see the heteroatoms. Suppose different heteroatoms are present in the ring system: oxygen, sulfur, phosphorus, etc. So heteroatoms in a given name is used as a prefix. So heteroatom, that is oxygen, sulfur, it is a prefix. We are using as a prefix. So these are some examples given here. The A ending, see all examples you see that for nitrogen aza, AZ, A, oxygen oxa, OXA, yes, thia, THIA. All nitrogen heteroatoms names are, the ending word is common, A. So the A ending is dropped if the next syllable starts with the OL. Okay. Thus, aza, suppose example is aza and irine. So what is the name for this? The properly written as azirine. So we replace this OL, that is A, from this name, and we can write azirine. Okay. This is the meaning of this. Next is the ring size. how many rings are there in a structure, is designed by the steam. Ring size is designed by steam. First we seen that prefix, then steam, that follows as a prefix 3 atoms IR. If suppose 3 atoms is there, then IR, 4 ET, then 5 OL, 6 iron, 7 EP, 8 OC, 9 ON, so on. Okay, you only understand these things only for the nomenclature. Okay, keep in mind that. Next, if fully unsaturated, if suppose fully unsaturated is there, the name is concluded with the suffix. For ring size 3 atoms, ENE, okay, except INE for nitrogen. Only for difference is there, for nitrogen it is INE and other atoms it's a ENE. Okay, 4, 5 and 6 atoms E, 7, 8, 9 atoms INE. Okay, so this is a for unsaturated, full unsaturated compounds. Next is the for fully saturated compound, that is suffix. What is suffix used for saturated compounds? That ANE. Okay, just keep in mind ANE for all ring sizes except the nitrogen, which is used as iodine for nitrogen. Okay, for ring size of the 3, 4 and 5 atoms and 6 atoms also. A prefix of hexahedro is used. Also the name of oxane, not oxane, is used for 6-membered ring with the oxygen present. Okay, so this is the one table is there. We can understand from this table some tricks. That is the size of the rings. These are the size 3, 4, 5, 6, 7, so and so. Then steam, what is steam used according to the size of the ring. For 3 IR, for 4 ET, for 5 OL, 5, 6 iron. Okay, these are the steams. Ring containing nitrogen and ring containing no nitrogen. Okay, without nitrogen, nitrogen. If nitrogen is there with unsaturated and saturated, suppose 3 ring size is there, so what we can say that steam as a IR, and unsaturated compound is there, we can say that INE. And suppose saturated is there, the iodine. Okay, so according to this tables you have to remember these things whenever we need to nomenclate the compound. For same, other than the nitrogen atoms unsaturated, we can say that ENE for 3 size of the rings and saturated ANE. Okay, just remember this table properly. You can print out this table and paste when you study in your study room. Okay, and remember this all sizes of the rings with the rings containing nitrogen as well as other than nitrogens. Okay, what are the short forms, so you can nomenclate the properly compounds. Next up, whenever we are nomenclating the compounds, you have to understand the priority of the heteroatoms. Okay, priority means first हमें कौन सा heteroatom लेना है, ठीक है, that is the priority. किसको priority देना है according to that. So this is the one chart is there, so we can say that priority of the heteroatoms for numbering system. So first of all, see the highest, this starting from this highest, there is oxygen, sulfur, selenium, etc., and this nitrogen, phosphorus. From this way we can say that the priority first oxygen, see this is the low, then again nitrogen, phosphorus, and this is the lowest way. So you can understand the priority of the heteroatoms. Okay, according to that you can nomenclate the compounds as per the priority. Okay, if suppose bicyclic compound is there, system where 2 rings share, suppose bicyclic, common single or double bonds which are said to be fused rings. A common case in which the benzene ring is fused with the heterocyclic rings. Benzene, 6-membered ring is there. So the name begins with the prefix the benzo. Okay, the point of attached is indicated by the letter to the defined as face of the heterocycle involved. Thus the 1-2 position on the heterocyclic rings is always a face, 2-3 is a B face. See, 1-2 position is there, we can tell as A face. For 2-3 it's a B face, 3-4 it's a C face, and so on. After the name is established, the ring atoms are given new numbers for the entire bicycle. The letters for the face of monocycles are placed inside the ring, and numbers of the ring positions of the bicycles taken as a whole are shown on the outside. See, according to this, we can say that if suppose 1-2 positions are there in heterocyclic ring, we can tell as A phase, 2-3 is there, B phase, and 3-4 and C phase, and so on. The final numbering always begins at the position next to the benzo groups, and the heterocycle atoms are given, that is the priority of the C. Already we seen that this is the priority. According to this priority, we can say that the numbering also. The position of the ring fusion bear the numbers of the preceding rings atoms with the letter as A attached. Okay, so example, see next. Here fused rings are there. Fused means what? Two rings are combined bicyclic. That is the benzo. Two rings is there. Benzo, we can say that benzo B pyridine. Benzo B pyridine. Then benzo C pyridine. Benzo C pyridine. Okay. Then 1H benzo B pyrrole indole. These are the examples for this. If two heterocyclic rings are fused, additional rules are required. Two heterocyclic rings are fused, additional rules are required. The parent ring is selected. सपोज पहले अपने हमको देखना है पैरेंट रिंग. इसमें पैरेंट रिंग कौन सा है भी? सपोज दिस इज द पैरेंट रिंग, दैट इज द pyridine. Okay, another ring is considered as a fused on. This is the benzene ring is a fused on, was observed for the benzene fusion. Same rules are as follows. If one ring contains nitrogen, it is considered the parent, and its name is placed last in the compound as a name. See the example, this is the parent ring, that is the pyridine. We also seen the last name of the pyridine, that is it is a parent ring because of the parent ring. If both rings contains nitrogen, the larger ring is present. Okay, larger ring means example, see, if suppose here also nitrogen is there, then larger ring's name will be present in that. If both rings are the same size, that with the most nitrogen atom is present, or if the same number of nitrogen atom is present, that fusion of the ring that gives the smallest number for the nitrogen when the bicycles is numbered is concerned. Okay, so these are the differentiation. Multi-cyclic system. Abhi multi-cyclic means what? More than two rings are attached each other. So this is example for this indole. And 1H benzo indole. See, this is the parent ring. So you can say that in a last name as a parent ring indole. And this is the 1H benzo. Okay. So multi-cyclic system are there. So this is the simple way to identify the nomenclature of the heterocyclic compounds. These are the reference. You can follow this reference also. Heterocyclic chemistry, R.K. Bansal, and other net sources and examples. Okay. Thank you so much, dear students. If suppose you have doubt in this topic, you can ask me in comments. And don't forget to subscribe my YouTube channel for further notifications for like these videos, and share this video to your other friends from other colleges also, so we can provide the informations and knowledge for them. Okay, thank you so much for listening me, and thank you so much.